Hi, I am Rakia Selman, and this lesson will discuss the concepts of relative risk, odds ratio, and rate ratio. The definition of these terms are shown, and relative risk can be defined as a ratio that demonstrates to show the risk of disease among the exposed and the risk among the unexposed. Odds ratio is a measure of association between the frequency of exposure and the frequency of outcome. And the rate ratio is the rate of the incident rate of the comparison group of the exposed and unexposed. Also, the rate ratio can be used when relative risk is calculated with incident rates. So how would you calculate relative risk? So to calculate relative risk, the formula can be expressed as A divided by A plus B divided by C divided by C plus D. And this identifies the rate of exposure divided by the rate of the unexposed. And as you can see, the variables are above on the variables of A, B, C, and D are on the charts of two cities, Atlantis and Camelot. And A represents the disease and exposure. B represents no disease but exposure. C represents the disease and no exposure, and D represents no disease and no exposure. So calculating the odds ratio, again the same variables will be used, A, B, C, D, and the formula is A divided by C divided by B divided by D. Again, the variables are represented as so. A represents the disease and exposure, B represents no disease but exposure, C represents the disease and no exposure, and D represents no disease or no exposure. And so calculating for rate ratio, to calculate the rate ratio of this case, the rate of cancer for heavy drinkers and non-heavy drinkers is used for both Atlantis and Camelot, which were the two graphs that were shown in the previous slides. Okay, for instance, the rate for exposed and unexposed for Atlantis was 0.018 and 0.002. The calculations for the rate ratio is shown as so, which is 0.018 divided by 0.002, and the same can be calculated for Camelot. The rate for the exposed and unexposed was 0.320 and 0.121. And the calculation is as such, 0.320 divided by 0.121. Okay, so as I mentioned previously, this graph here showed for Atlantis, and the calculation for Atlantis is dealing with the risk of getting cancer among heavy drinkers and non-heavy drinkers. And so the risk, the odds, and the rate of this first half is shown, but I want to get to the relative risk for getting cancer, comparing heavy drinkers and non-heavy drinkers. And so if I go back to the variables that I used before, 18 will represent A, 2 will represent C, 482 will represent B, and 498 will represent D. And so if I go down to my formula here, where it says 18 divided by 18 plus 482, 18 is again the disease and the exposed, divided by 18 plus 482, which is the total population. And we're going to divide that by 2. Again, 2 would represent the disease and no exposure. So 2 divided by 2 plus 498. Again, 200 plus 498 is 500, which is the total population. And so that came out to 9 times greater risk of cancer among heavy drinkers than non-heavy drinkers. The odds ratio, again, if you look at the formula, and the formula is A divided by C divided by B divided by D, okay, which gives you 18 divided by 2, which will divide by 482 divided by 498, which gives a ratio or a rate of 9.299. And the rate ratio is demonstrated from your rate at the previous, at the top, which deals with the person years. And so that's 0.018 divided by 0.002. And that gives a person who is a heavy drinker 9.137 times than a non-heavy drinker. And so the same calculations can be done for Camelot. Again, if we follow down to the relative risk and use a appropriate formula that was discussed previously, and go ahead and the 250, this first 250 will be A, the second 250 will be B, 120 will represent C, and 380 will represent D. And so according to the formula, it will be 250 divided by 250 plus 250, which is the 250 plus 250 gives a sum of 500, which is the total population, which can be divided by 120 divided by 120 plus 380. And that is a 2.08 times greater risk of getting cancer among heavy drinkers than non-heavy drinkers. And so the I ratio, again, using the same formula of A divided by C divided by B divided by D, will give you 250 divided by 120, which divides by 250 divided by 380, which gives you 3.167. And the rate ratio, you're dividing those numbers from the person years, 0.320 divided by 0.121. Okay, so when can you use the odds ratio for relative risk? And that can be determined when the disease being studied is not a frequent one. Also, the cases are representative of all the people with the disease. So they represent all of the people who have that disease with regard to their exposure history. And the controls will do the same as well. They represent all of the people without the disease with regard to their exposure.